are working with linear systems now, which we're going to deal specifically with system of equations. Well, you should have had some experience back in Algebra 1 with the system of equations, which is basically just having two or more equations that share the same variables, and they're solved at the same time. And an example of that is things like, you get an equation like 3x plus 4y equals 12, and then another equation that says something like negative 3x minus 12y equals 16, and you solve for what x and y is. And basically, the point that you're trying to find is the point of intersection of these two graphs, if you were to graph them. So that's one thing that we want to know, is that when we do solve by graphing or by looking at the table, the point of intersection is the solution, okay, where they intersect at. Right? We're just looking at there's one point that works for both of these equations that's the same, right? There's some certain xy point that works for both those, and there's only one that is, unless they're the same line or they're parallel lines, and we'll get into that later. But just know for graphing, the point of intersection is the solution. Okay, and these other ones we'll touch on later. We'll do these next, and these are solving it algebraically. And depending on how your equations are written, you might do one or the other, from graphing to substitution and elimination. And then lastly, these matrices, we'll do this later in the year, but we're not going to look at it right now. And these are kind of convenient once you know how to do matrices, because our calculator can solve those. So let's use a real-world example here where we can use graphing for a system. So it says Megan is a good saver. She had $1,250 in a savings account and added $185 each month. Whereas Michael loves to spend his money. He inherited $9,800 and spent $290 each month. Well, let's write an explicit equation for each of these situations. So an explicit equation, remember, in this case, we want to use our slope-intercept form, so like y equals mx plus b. Well, if I take a look, could I find the slope of each of these guys? Remember, slope is the number that's in front of the x. Well, yeah, always look for a rate. Remember, slopes are also rates, where it's like, look for words like per or each or things like that, where it's like something per something. Well, for Megan, she did, added $185 each month. So there's her slope. Whereas Michael spent $290 each month. So those are reoccurring things, right? It's $185 each month. Or $290 each month. So that's our rate. So for Megan, we're going to say y equals 185x. That's the slope. Well, then her initial amount, remember that's the y-intercept. That's our b. So here's the initial. Well, so we say plus 1250. Okay? Let's just be careful when we write Michael's. Okay? So when I write y equals, I'm going to hold off for the slope. I know he started at 9,800. I can see that right up here. There's this initial amount. So I'm going to put that first, plus 9,800. But what about for the slope? Is it 290x? Is that okay? Do I just put 290x? Well, what's happening? He's spending that each month. So instead of being a positive 290, it should be a negative 290x, because it's decreasing by $290 each month. So you have to really think through your situation. Sometimes it helps to reread both to figure out, should they be positive, should they be negative, so on and so forth. Well, what we want to do is we want to find out when Megan will have more money than Michael. Okay, so if I think about these graphs in general, I would have Megan's situation would be going up like this, and we have Michael's situation starting up higher and going down like this. So basically, we want to find their point of intersection, which means the point that would work for both of these equations. And just beyond that, right, Megan would have more money than Michael. So let's go ahead and put these into our calculator. So we'll grab our calc. Okay, so make sure, make sure your mode's in function, first of all. I should go y equals. Make sure all your plots are turned off up top, which I'm good. And I already have my equations written in. Y equals 185x plus 1250. Good. And then y equals negative 290x plus 9,800. Good, got those typed in. Okay, so I'm going to go ahead and graph it. Uh-oh, nothing appeared. What's the quickest way to set your window? I mean, I could go in my window and reset these things, but what's the quickest way? Well, you have this zoom button here. We talked about this the other day. My favorite thing to do is to scroll down in the zoom to the 10th one and go zoom fit. I also could just hit 0 and it should take it, but I'm just going to go down to zoom fit and hit enter. And that should fit my lines. Uh-oh, it still didn't give me my intersection. So you may have had the graph that I just had, or you might have something like this. Sometimes it doesn't put that point of intersection, so we might have to adjust it a little bit. So before we adjust our window, one way we could do is we can go into our table and actually look this way as well. So instead of looking at the graph, we could also look at our table. So our initial amounts are listed right here. And then if we look in 1 month, it shows Megan's and then it shows Michael's. So I can just keep going down and I can look to find when they equal, and that would be our point of intersection. Looks like we're getting closer. There we go. So in the 18th month, they are equal. And then if you look in the 19th month, Megan would actually have more money than Michael. So, I mean, there's our answer, first of all. So I could say in 19 months, Megan would have more money than Michael. And if we look, the solution, like if I was finding the point of intersection, we found that in the 18th month, they were the same at 45.80. So if I want to get that point of intersection, I might have to change my window here. So I'm going to go window X's. Well, I'm not going to have negative months. And we're going all the way up to at least the 19th month. So I'm going to look through the 20th month, count by ones, that's fine. Not going to have negative money. And let's see, Michael had 9,800 to start off, so I'm going to start with 10,000. And we'll count by thousands for the scale. There we go. So sometimes you might have to adjust your window, but hopefully I should find the graph. Okay, and if I wanted to find this exact point of intersection, remember you can hit trace and be on the line and look closely, but if I move it over there, I'm still going to be taking an estimate at where their intersection is. Right? It doesn't give it to me exactly. So if I want to find it exactly, you see how you have this blue calc right here, or the calc right above the trace? So I'm going to hit second and go into my calculations, and I want to find their point of intersection. So I'm going to go down to intersect, or I could just hit 5. And it's going to say first curve. Well, all I do is I just am on the first one of the lines, and I hit enter. Then it's going to say second curve. Well, where's my second line? Okay, I'm on it. So I'm going to hit enter. It says make a guess at where it's at. It really doesn't matter where you guess. You can move over and take your guess, but I could just hit enter right away. Even if I'm far away and I hit there to guess, it's still going to find the point of intersection. So that's how you solve it using your graphing calculator by graphing. You can actually find the point of intersection. So 18, 45, 80. All right, let's look at one more example here. So we had 2 cell phone plans. Plan A, $14.95 a month, 10 cents per text, and Plan B, $17.95 a month, 7 cents per text. We're going to write explicit equations, but should we be looking at discrete or continuous graphs? Well, remember, discrete, those are like our scatter plots like we did with recursion, and continuous is actually a line. So definitely continuous now. When we're looking at systems of equations, we don't want to look at discrete anymore. So let's write some equations. Well, so for Plan A, if you notice, it says per, so this must be our slope, the 10 cents, and our initial amount right here, $14.95. So I should say y equals 10x plus $14.95. Uh-oh, I think I just heard somebody yell at their computer. What did I do wrong there? Why is that incorrect? Oh yeah, one of these is in dollars, and the other one is in cents. They need to be consistent. Okay, so I can convert either this to cents, or I can convert my 10 cents to dollars. I like to keep it in dollars. So what's 10 cents as a dollar? It's 0.1 or 0.10. So I just need to put a decimal there. So it's really 0.10x or 0.1x. And then I'm going to do the same thing for Plan B over here. So y equals, here's my slope because of the word per, right? 7 cents per text. So not 0.7, that's 0.07, right? Because 7 cents is really 0.07. And then plus, forgot my x, 17.95. So just be careful about how things are worded when you write your equations. Okay, and let's figure out when they're the exact same. Let's find out when these plans, so right away it looks like plan A's the better deal because it's cheaper right off the bat, but you pay more per text. So let's figure out when these plans would be equal to each other. How long until like plan B is going to be the better deal? So let's go to my calculator and we'll type these in. So equation editor, and we got 0.10x and plus 1495, 5. There we go. So I'm going to go ahead and graph, which I didn't see it very well, so I'm going to zoom fit right away. Remember, it's the 10th one, so I could just hit 0 to get zoom fit. Let's see if it gets my point of intersection here. There's 1, there's 2. Oh, didn't quite get it. So I could look at the table. I might do that. Let's go to my table. It's taking a little while. Be a quicker way to get there. Yeah, I could go to remember my table set, and maybe I could start at 0 and maybe just count by every like 20 texts. So now let's go look at my table. Now there we go. So it's right around 120. So now I might go back and I'm going to go to about the 120th text, and let's count by ones again. And there we go, I found it. 100 texts, they are going to be equal. Okay, so then if I want to adjust my window so it shows up on my graph, so remember I got to get to my 100 text. I might even go to like 150, and I'm going to count by 25s. And I want to be able to see more costs. So let's go up to like, well, what was the cost at that point in time? So we got to get up to at least $25. So let's go up to $30. And I'll count by 5s. All right, so let's take a look at our graph. That looks better. So it's really hard to see, but remember, I can go to my calc, right, second calc, and go to their intersection. Remember, select both lines, first curve, second curve, take my guess. And there we go. There's my point of intersection. So 124.95. So on the 100th text, so basically on the 101st text, plan B would be better. So if you know that you're going to text less than 100 times a month, then plan A would be the way to go, right? So 100 times or less. If you're going to go more than 100 times, 100 or more, I would go with plan B. If you're going to text exactly 100, it doesn't matter which plan you have, right? So that's where a system of equations come into play. And sometimes looking on a graph or on my table on my calculator is helpful.